Okay, this is chapter 9, Fundamentals of Hypothesis Testing, one sample test. Later on, we will consider 2 samples, 3 samples, and so on because we can draw many samples from our population. So, in this chapter, we will develop the basic principles of hypothesis testing. Hypothesis means we assume something and then we test it, is it correct or not, and how to use hypothesis testing, mean or proportion, and then we will discuss these 3 points as well. So as I said, hypothesis is a claim or assume. So in this chapter we will test the claim made by the owner and then we will prove it or we will disprove it. A hypothesis is a claim, whatever claim a population is making. For example, a factory owner says that the average diameter of his bullet is 30 mm. In that case, his claim is mu 30 mm because everybody will make claim about the whole population, not only on the sample. For example, if you want to buy some computers, he will talk about that the quality of his computer is very good, bad, or worst. He will, whatever he will make the claim, he will make the claim about his whole population. Or let's take another example. Let's say you want to buy some A4 size paper with 90 mm thickness. The factory owner will say that the average thickness of his paper is 91 mm or 90 mm. He will talk about the whole production of his factory, not only one sample. So the claim is always made about the population parameters. So likewise here you can see the mean monthly cell phone bill in this city is $40. So this is the claim that the mean bill of all people living in this city is 30. And similarly, later on we will discuss the proportion and we will make the claim about proportion as well. I don't want to discuss it so far, so we just focus on the mean. Here you can see that we always, as I said, we always make the claim about the population, so we denote the claim by H0. This is the claim, and whatever we will test we will call it H1. So he is claiming that the average the diameter of manufactured bullet is 30 mm, so mu is 30 mm. So this is how we denote his claim. H0 is his claim that every diameter of the bullet is 30 mm, and we always make the claim about population parameter mu, not about the sample parameter. Then we make the alternative that no, the average diameter of bullet is not 30 mm. Whatever we test is our H1. This is very important statement. I am repeating it. Whatever we test, we say that this is H1. We are testing that his diameter, the diameter of his bullets is not 30 mm. So H1 is mu 30, and whatever he claims, he is claiming that diameter is 30 mm, so it is our mu. Then sampling distribution of the test statistics. This is our exception region, this is our rejection region, and this is our exception region. We will discuss it later in detail in the last slides of this topic. It would be better for you to understand at that stage, not here. Then again take level of significance alpha. If he says that he is 90% confident, then alpha is 10%. Same concept from the previous chapter. If he says 95% confident, alpha is 5%. Before, he was in chapter 8 he was talking about confidence interval, but now in this chapter he will talk about margin of error, alpha. You will be given alpha is 5%. It means you are 95% confident. If alpha is 10%, it means you are 90% confident. In this chapter you will be given alphas, not confidence intervals, but whatever that is given you will calculate it exactly the same thing what we were calculating in chapter 8, but in the other way. So here you can see that he says that the average diameter of his bullet is 30, and we go against it. We say no, it is not 30 mm. H0 is his claim, H1 is what we are testing. So alpha level of, this is if in your null, this is called null and alternate hypothesis. If in your null and alternate hypothesis you have equal and not equal sign, it means you are dealing with two-way sample, with two-way test. Two-way, whenever it is two-way, then we will have alpha by 2. We will divide alpha into two parts because it is two-way. Half alpha will come here, half alpha will come here. If the value fall in this region, we will reject his claim. If value fall in this region, we will accept his claim. And here in the middle we always write mu, his claim already know. What test we will use now? Hypothesis test for mu. Hypothesis test for mu. If sigma is known like the previous chapter, then we will use z-test. If sigma is unknown, then we will use t-test. Students always make mistake in deciding either they need to use z-test or t-test. I make it very clear. If sigma is given, then z-test. If sigma is not given, then we will use t-test. Okay, what is z-test? This is our z-test which we have already used in chapter 8 and chapter 7 as well, I think so. So the same formula, we call it z-stat equals to x bar minus mu over sigma divided by square root of n. So you know what is n, you know what is sigma, you know what is mu, so you don't need to worry about this. Just substitute the values and you can get the answer. So everything is same. Convert sample statistics x bar test statistics. Determine the critical z value from level of significance from the table which is given in the book, and then decision. We will discuss it how to take the decision as well. Okay. As I already discussed, this is exception region, like do not reject, and this is rejection region. If values fall in this region, we will reject it. If value fall in this region, we will not reject it. There are steps of hypothesis of testing. Very first step, we decide null and alternate hypothesis. Choose level of significance alpha. If it is given, that is better. If it is not given, you can choose your own level of significance, 1%, 5%, 10%. That is your choice, that how much margin of error you can afford. In real life, this is your decision, that how much margin of error you can afford. So if it is given in the problem, that is better. If it is not given, you can choose your own. Determine the appropriate test and sampling distribution. If sigma is given, then you will use z-test, which we are discussing now. And step 4, determine the critical value. Critical value z alpha by 2 for 5%. We know that it is plus minus 1.96 from the table. So that is the values which you should know how to calculate it. Otherwise, you can directly write it. Collect the data and compute the value of test statistic. In step 5, you will substitute the values in the formula, this formula, and then you will calculate the z statistics. Make the statistical decision. I will explain it in the example how to make the decision. Here we solve one example. Test the claim that the true mean diameter of a manufactured bullet is 30 mm. Assume sigma is 0.8. I don't know you can read it or not. Assume sigma is 0.8. We are given sigma, so we will use z-test. He says that the average diameter of the bullet is 30 mm. So h naught mu equals to 30. H1 is always against it. If it is equal, so it would be not equal. So H1 is not equal. So it is two-tailed because in null and alternate hypothesis, when we have equal and not equal sign, then it is two-tailed. So this is very important step to decide it is one tail or two tail, because if it is two tail only, then we will divide alpha by 2. Specify the desired level of significance and the sample size. We say that we test for alpha 5%, which is 0.05, and we take a sample of 100 bullets. Determine the appropriate technique. Because sigma is assumed that it is known, then we will use z-test. Determine the critical value for alpha 0.05 in two-tail test. Z value is 1.96. For two-tail, we have already discussed it previously that for 90% Z alpha by 2 is 1.64, for 95% Z is 1.96, and for 99% or alpha 1% Z alpha by 2 is 2.56. You can directly use these values. If you are using alpha other than 1, 5 and 10%, then you can use others and then you can calculate it. Okay, so x bar is 29.84, sigma is 0.8, n is 100. You can substitute the values into this formula. You get z stat minus 2. So your z stat is minus 2 and your z critical is minus 1.96. Z critical value z alpha by 2 for alpha by 2.05, z alpha by 2 is minus 1.96 here and 1 plus 1.96 here, and our z statistics is minus 2. So minus 2 comes here in this area. So this is our rejection region. So here z stat minus 2 is less than minus 1.96. So the test statistics is in the rejection region. So we will reject his claim that the average diameter of bullet is not 30 mm. So that is our decision, because minus 2 is here it is minus 1.96, so definitely minus 2 will come somewhere here. So z stat minus 2 less than minus 1.96, reject the null hypothesis and conclude there is sufficient evidence that the mean diameter of manufactured bullet is not 30 mm.